I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we are going to consider some challenge questions based on nonlinear patterns. You need to find explicit pattern rule and write down few terms. The question here is, find the general term and then write the next three terms for the sequence. Question 1. 4, 12, 24, 40. Question 2. 3, 14, 39, 84, 155 and so on. Question 3. 0, 3, 8, 15, 24, 35 and so on. How do you solve such questions? We are going to understand this strategy. So whenever you have sequences given as here, we should find what type of sequence it is. So first let us find the type of sequence. Best way to find the type of sequence is to figure out what is the first difference. First difference is the difference between consecutive terms. That is to say, difference between consecutive terms. So consecutive means the terms which come one after the other, and then we can find how the sequence is increasing. Well, all these are increasing sequences, as you can see. So let's figure this out. You can also pause the video at this stage, solve the question, and then check with my solution and also understand the strategies which we are going to adopt. Some are very interesting strategies which we will discuss in finding these nonlinear patterns. In case you want to learn from me, you can always join my classes by sending an email on the address given. Many of my students have done extremely well and have been rewarded. Here is a clip.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our summer classes and get ready for bright future. Okay, now let us see how do we approach and solve such problems. So as I was saying, we need to find the first difference. First difference is the difference between the consecutive terms, means difference between 412, 1224, 2440 and so on. So let's figure this out. Here is our question number 1. Let's write down the terms. We are given 4, 12, 24, 40 and so on. The first difference is the difference between the consecutive term, that means 12 minus 4, which is 8. 24 minus 12 is 12, and then we have 40 minus 24. So from 10, when you take away 4, you get 6, and 3 take away 2 is 1. So that becomes your first difference. Since first difference is not constant, it is not linear. Now, let us find the second difference. So between 12 and 8, the difference is of 4, and between 16 and 12, 16 minus 12 is also 4. So we see that it is a non-linear but it is quadratic in nature, right? So in that case, if n is the term number, in that case, the formula for the general term will definitely include n square, right? So we'll say, let the term number be n. So I will also tell you a hint. From the constant second finite difference, we can actually find an expression also. We'll look into that later, okay? So, well, in the first case, we know that in the formula, we have n squared plus something. So that is what we need to now find. What are we adding to n squared to get the sequence? So I hope we have solved a very interesting part of the puzzle for the question number 1. Now let's look into question number 2 and find the first difference. Now I think you're absolutely clear about how do we find the first difference, so you can do it along with me. This time the numbers are 3, 14, 39, 84, 155, and so on. The difference between 14 and 3, 14 take away 3 is 11, 39 take away 14, 9 take away 4 is 5, and 3 take away 1 is 2, so it is 25. From 84, if I want to take 39, I can take away 40 first and then add 1, right? So we get 5 here, and to take away, 14 takes 7 minus this gives us 45. Okay, and now from 155, 5 take away 4 is 1, and then 15 take away 8 is 7. So we have 71 as this difference. So that is the first difference, means non-linear. So you get the idea. All of them are non-linear patterns, and we need to find the pattern rule. Well, let's find the second difference now. 25 take away 11 is 14, and 45 take away 25 is 20. 71 take away 45 is what? 11 take away 5 is 6, 6 take away this is 2. So it is not quadratic, right? So we need to continue further and then see. So now we have 20 take away 14, which is 6, and 26 take away 20, that is also 6. The third finite difference is constant. So it is cubic, right? That means it is cubic. Cubic means the formula will include n cube plus something. You get the idea. N cube plus something will be there in the formula. Let's also look into the third question, which is 0, 3, 8, 15, 24, 35, and see what type of sequence is this. It is 0, 3, 8, 15, 24, 35. The first difference in this particular case is 3. The second, 8 take away 3 is 5. Then 15 take away 8 is 7. 24 take away 15 is 9. 35 take away 24 is 11. And now if I find the second difference, which is going to be 2, right? 7 take away, so we see clearly that the second finite difference is constant. So second we can write like this, second finite difference. So we sometimes use the word delta to difference, second difference constant in short form, which is 2. And therefore, it is quadratic. And the equation will involve n square plus something. You get the idea. So from these examples, we see that they are all nonlinear, and we do get an idea of what type of equation it could be, right? So we do have n squared term in this. Now this seems to be much simpler than the others. Why not start with the solution of third one first, right? Okay, so we see that the finite difference is constant for the second finite, so n squared is the term. So if n squared is the term, what is the other term? Okay, so let's continue with this. Let's write down the term numbers now. So here is the approach towards the solution. So we have figured out that second finite difference, let me write it like this. Second, right? 2. And that was equal to 2, right? Second finite difference equals to 2. And therefore, we have a term n squared, right? So we have n squared plus something, correct? So let's look into this sequence, which is 0, 3, 8, 15, 24, 35, and so on. So what is the value of n? Well, let's write down the value of n, which is 1, 2, 3, 4, 5, 6. These are the term numbers. And what is n squared? Square of these will be 1, 4, 9, 16, 25, 36. And what do you notice? The relation. How do you get from n squared the other term? Well, take away 1, right? So in this case, if you compare the two, we can see definitely that I have to take away 1 to get my sequence. Is that clear to you? And therefore, explicit formula. You can easily see is any term is equal to n squared minus 1, correct? So the next 3 terms will be what? 7 squared is 49. So 49 take away 1 will be 48, right? 8 squared is 64. Take away 1 will be 63. 9 squared is 81. And 81 take away 1 will be 80. So that is how you can write down the next 3 terms. So we have the general formula, which is n squared minus 1. And the next 3 terms are given as shown here using the formula. You get the idea, right? So how do you calculate? You write the term number. Let's write down term number 10. In that case, it will be 10 squared minus 1, which is 100 minus 1, 99. That is going to be the next term, and so on. You see how? Using the explicit formula, we can easily find the other terms. I hope this part is absolutely clear, right? Okay. Now let's get back to question number 1, which was also quadratic in nature. Can you figure this out? What could be the formula? Use a strategy very similar to what we used in answering question number 3. Okay, let's copy the sequence and figure this out. So the sequence for us is given as 4, 12, 24, 40, and so on. And if I write the value for n, so this is my first term, this is second term, third term, fourth term. We'll find what fifth term is, and n squared is what? 1, 4. Square of 3 is 9, this is 16. Now, from these terms, how do we get 4, 12, 24, and 40. What should we add to get those terms? That is one thing which we are looking into. Let me also remind you that the finite difference was, in this case, 4. Finite difference was 4, right? So let's write down that the second finite difference is 4. Now, when the finite difference was 2, we had only 1 n squared. But when it is 4, in that case, we will notice that the formula could be 2n squared. So if I do double this number, I get 2, 8, 18, 32. You see that? Now, if I have these numbers, what is left from the major formula? 4 take away 2 is 2. 12 take away 8 is 4. 24 take away 18 is 6. 40 take away 32 is 8. So do you see how it is adding up? 2, 4, 8, 6, 8. For first term it is 2. For second it is 4. For third it is 6. So twice the term number, right? So that means this is twice the term number. Correct? And therefore, we have the general rule, which is the nth term is equal to 2n squared plus 2n. Using this, you can find the other terms. That is one way of solving this particular question. Well, if you simplify this, you learn that you can take 2 and n common and you get n plus 1. So the simplified formula is 2n times n plus 1. That is very interesting to find. So we could have approached it differently also. Do you see this? This is our learning process. So the terms 4, 12, 24, 40, you could think like this. I could take 2 common, right? And then the sequence would be, I'm just dividing all these terms by 2. I get 2, 6, 12, 20, and so on. Do you see that? So this is my alternate approach. Since all were even numbers, I could factor 2. So we get 2, 6, 12, 20, and so on. And 2, 6, 12, 20, this sequence is very, very important. You can see that each term in this sequence can be written as product of 2 terms. 2 is 1 times 2, right? 6 is 2 times 3. 12 is 3 times 4. 20 is 4 times 5. Right? So you see n times n plus 1. Term number 1 times 1 more than 1. Right? Do you see that formula now? So that was a very, very effective approach. So sometimes it is better to find by splitting, as we did in answering question number 3. At times we could use a different method, common factor. So here we did a common factor, and that product of consecutive terms. Perfect. That is how we got the solution for this particular question. Now the challenge question for us is to answer the third one. In the third one, we have, in the second one, right? Second one. In the second one, we have a cubic equation. 6 is the third difference. So we see that the third difference is equal to 6. And therefore, if n is our term in the equation, we have n cubed. plus something, right? Let's find what do we add to n cube to get our formula. Let's rewrite what is given to us. It is 3, 14, 39, 84, 155. N is 1, 2, 3, 4, 5, and so on, correct? N cube is 1, 2 cube is 8, 3 cube is 27, 4 cube, 16 times 4, 64, 5 cube is 125. 25 times 5. Now once you have this, in that case, what is left? Let us check what is left. So we are now looking into these two equations. Subtract. 3 take away 1 is 2. 14 take away 8 is 7. 6. And 39 take away 27 is 12. 84 take away 60 is 20. And here we get 5 and then 30. We get the sequence 2, 6, 12, 20, 30, which we saw last time also. You get the idea? Well, 2 is 2 times 1. You can write 1 times 2. So this is like, I may write 1 times 2, right? First term times 2, double the first term. This is second term times 3, 3 times 4, 4 times 5, 5 times 6, and so on. Correct? So that means we have to add to n cube n times n plus 1, which is n times n plus 1. Correct? And that gives us the general formula, Tn equals to the n cube, I have to add n times n plus 1. You see how we have our sequence. So that is the best way to solve such questions. I hope you find it interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Now, before we end, let me ask you a question. Based on what we have done, here is a question for you to practice. So this is your practice question, right? I'd like you to find the answer for this particular question and then post your answers. In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best. Join my classes by sending an email on the address given. You can register for any of the courses which we are offering. Thank you and all the best.